Start recording. All right, so today we're going to be looking at inverse functions. Basically what an inverse function, the easiest way to think about it is if you think back to like your science class, like a lot of times you'll have like formulas or kind of like equations to use. Like for example, you might have an equation that goes from Fahrenheit to Celsius. The inverse function would do the opposite. It would go from Celsius back to Fahrenheit. So like, for example, if you had Fahrenheit going to degrees Celsius, the inverse function would basically do the opposite. Basically any conversion formula you can think of, like, and for example, like money, like for example, if there's like a formula to go from American dollars to, I don't know, Canadian dollars, well, the inverse function would go from Canadian dollars to American dollars. So that's what inverse functions are used for, just so you can kind of get like an idea of why we're doing what we're doing. Because pretty much we're not really going to look at many applications today, but you have used inverse functions in your science classes, whether you had to find them yourselves or whether you realized they were inverse functions or called them that. You've dealt with these before with prior experience. But let's kind of get rolling into these to kind of see our concepts. The first concept is if we're given a relation, which is just like a point x and y, find the inverse. The big idea here is you just swap your x and y. So you don't mess with the signs, you don't do anything like that, you just swap the x and y around. So like this first one, -2, 4, would turn into 4, comma, -2. So notice the 2 stays negative, the -2 stays negative, the +4 stays positive. We don't mess with the signs, we just literally swap them around. So 4, 7 would turn into 7, comma, 4. 0, 11 would turn into 11, 0. So I'm going to launch a Zoom poll really quick. I'm going to try and do this more just so it gives me more feedback. But how about you try the last question? So I don't know if it pops up if you can't see it, but what would the inverse of this last one be? So that if you see the Zoom poll, I made it like multiple choice if you want to pick your answer. But if you can't see it, I mean, just try it anyways, or let me know. It sometimes gets stuck behind like your window. Let's see if you can answer this one. So that's our first concept. So basically, if you have a point, just swap the numbers around. Nothing too crazy. Concept 2, and honestly, this is the one you probably won't come across too much, but I thought I'd show you just in case, I mean, you come across it. But how do you find the inverse of a mapping? If you don't remember what a mapping is, it's like these ovals with arrows going from your x to y. One thing about some notation, f of x is like your original function. This f with the -1 of x is your inverse. Like how you read this, this is the inverse of f of x. Like that's how I, like when I see this, that's what I say in my head. That's the inverse of f of x, or f of x is inverse. But if I don't know if you remember, it's been a while, but when we did matrices, like our inverse of our matrices, we would put a up to the -1. So anytime you're dealing with functions, or a lot of times when you see a -1 power, that's referring, like with letters and stuff, that's referring to an inverse. But basically, to find the inverse of a mapping, you draw your two ovals, like for your x and y, and basically you swap the numbers around. So the y numbers now go in the x oval, and then the x numbers go in the y oval. So -3, 0, 4, and 9. So just like the points, the x and y's all swap places. But then we still need to do our mappings, or the arrows. So my advice is just do one at a time. So 3 goes to -5. So we got to do the opposite, or sorry, -3 goes to +5. I think I said that wrong. So we got to do the opposite. So +5 now goes to -3. Our next arrow goes from 0 to -2. Oops. So we got to do the opposite. So -2 to 0. Our third arrow it's kind of like sloppy. It's coming from the 4. and it goes to the 2. So we do the opposite. So 2 would go to the 4. Then our last one, we have 9 goes to 0. So that means 0 goes to 9. Oops. Sorry, it's a little sloppy, but that's the idea. Like I said, probably won't come across too many questions like these, but I just wanted to show like it's basically the same idea as concept 1. You swap around the numbers, but just make sure those arrows kind of do the opposite of what they did in the original as well. Because that's the really the key idea of an inverse function. It basically undoes or does the reverse of the original function. Like I said, a lot of times in science classes, you might have a formula that converts Celsius to Fahrenheit. Well, the inverse would go Fahrenheit to Celsius. So because the next thing we're going to look at in concept 3 is we're going to look at finding the algebraic inverse. Basically, if we have a formula or a function, we're going to try and find the function that does the opposite, essentially, or basically undoes what our original function was. So there's really 4 steps we're going to follow. And as you get better with these too, if you want to, if you can kind of combine some steps, or you can kind of skip a little bit of write-in, or there's definitely some shortcuts, but especially when you're starting off, I would recommend you go through these 4 steps, because sometimes it's easy if you try and combine things, you might forget to do something. So, but definitely as you get better, you can definitely probably combine steps 1 and 2 and stuff. But nevertheless, step 1, we want to rewrite but replace f of x with y. Step 2, we're going to swap our x and y. Step 3 is kind of like where most of our work comes in. We're going to get y by itself, or solve for y. And then we just write our answer with that inverse function notation. So step 1, so let's look at this first one. So step 1, we rewrite our equation with a y equals. Step 2, we swap our x and our y. So like our x and our y, they're going to trade places. So we would have x equals 15y minus 1. Step 3, we want to solve, we want to solve for y. This is where most of the work really comes in. Step 1 and step 2 just kind of become a routine once you get used to it, at least. But we want to get y by itself. So the first thing I'm going to do is add the 1 over to the other side. So those are not like terms. Like you can't combine x and 1. Like they both don't have x's, or they're both not constants. So they stay separate. So that would just be x plus 1 equals 15y. Then the last thing, to get y by itself, since this is 15 times y, I got to divide that to the other side. So I'm basically going to end up with, and I usually just leave it as a fraction, like just keep it over it like that. But that's going to be step 3. And here, I'm going to make this a little bit smaller because I write too big. Okay. Right. But then step 4, that's basically our answer. We just want to write it with this function, this inverse notation. So you do f negative 1 of x. That's the inverse of our function, is what we got here. So this x plus 1 over 15. And I know you might be kind of wrapping your head around the process still, but kind of look at our original function and look at our answer. Like you kind of see they do the opposite. Like this one is 15 times x. This one's divided by 15 because that fraction. This one had a minus 1. This one has a plus 1. So this inverse function basically is doing the opposite, or it would undo that original function. And sometimes like you can almost, like for a question like this, you might have been able to be like, well, why can't we just go straight to the answer? Sometimes it's not as easy as seeing it like that. A lot of times, even if the inverse, it's not always as obvious. Like if this does seem obvious to you, like a lot of times you really do need to go through these processes, because even the inverse function, even though it does undo the original function, it doesn't always look that way necessarily. and especially for anyone that just joined, these are the 4 steps we're doing. Here, I'll try and keep it open with the steps. Let's look at another one though. So step 1, we're just going to rewrite this function as y equals. Step 2, you're going to swap your x and y. So that would be x equals 1/3 y plus 7. So those are steps 1 and 2. Like those will always kind of be like the same process. Okay, step 3, we want to solve for y. So I mean, the first thing you're going to do is subtract the 7 over. So those aren't like terms, so they stay separate. So that would just be x minus 7 equals 1/3 y. To get rid of a fraction in an equation, you can multiply by the reciprocal. Like, so we got to multiply both sides. And when you multiply the left side, you got to multiply everything by, or really distribute it, because this would cancel. So I got y by itself. 3 over 1 is just 3. So I mean, if I distribute, that would be 3x minus 21. And here, I'm gonna, let's try it again. Sorry, that part's gonna copy from the other problem, but I'm gonna paste this. Just give myself a little bit more room. Okay. All right, then, so that's basically our answer, but step 4, basically we want to just rewrite it as switch the y with this inverse, and then you copy that like x part, so the 3x minus 21. And you might notice it's not as obvious, like, because you're like, I mean, you can see it's multiplying by 3 instead of multiplying by 1/3, but the plus 7 minus 21, it might seem a little bit weird. So like I said, it's not always as easy to just kind of look and see that it's doing the opposite, but basically this would reverse the 2 functions. So if you plugged an answer into the first function, got your, like, say you plug 2 into the first function, get your answer, and you plugged it into this inverse function, it would take you back to where you started, kind of thing, if that makes any sense. So like, I don't know, like let's say I plugged in, if I plugged 3 into this function for x, like 1/3 times 3 would be 1, plus 7 would be 8. If I plug 8 into this function, I'll get back to that 3. Like, if that makes sense. I don't know if I'm making it more confusing than not. Like, so like I said, if you plug 3 into here, you're going to get 8. So then if you plugged 8 into this bottom function, it would take you back to the 3. It's kind of like it would loop you back to where you started, kind of thing. But if that doesn't make sense, it's not that big of a deal, but just so you could kind of see that it does kind of reverse or take you back to where you began. Let's look at one more together. Honestly, I'll have to double check, but I wasn't planning on giving you too many questions with like a power of 2, but maybe it might be nice to see just in case you're in a class, like maybe if you're taking a class at college next year, like you're trying to get your math credit. I mean, unless, I don't know, maybe you are. I'm just assuming maybe most people in here, you probably don't want to like be a math major. But if you do, I mean, that's go for it. I mean, but most people, like most of my seniors are like, I hate math. Like, but if you enjoy it, I mean, go for it. But most of you guys, I'm assuming you'll probably just have like one math class for your program you're taking. Like if you want to, basically anything you want to do, if you want to be like a nurse, or you want to go into business, or you want to go into, I don't know, psychology, or you want to go into what else, education, sociology, you're at least going to have to take like one math class. All right, so that's step 1. Step 2, you're going to swap your x and y. I don't know if you know, the opposite of a power of 2 is the square root. So we would, because we're trying to solve for a y, so we would square root both sides, because basically that would cancel out this power. So then we would add the 2 over. So to write it with the inverse notation though, would be like this. But if I kind of lost you in this third one, don't worry too much. Like I said, most of the questions you're going to see are like examples 1 and 2. I don't know if like, for example, if I was giving you a quiz, I don't think I'd put a question like this one I just did, unless it was for like bonus maybe. All right, I want you guys to try this last problem here, this f of x equals negative 5x minus 11. See if you can kind of, I don't know if I can squeeze it without it being too small, but see if you can follow those 4 steps. Give it a try. Here, and once you work it out, I'm going to launch a poll. It's multiple choice. See if you see your answer on this poll, or let me know how you're doing. But I'll give you guys, I don't know, maybe 2-3 minutes. This should be more than enough time. But try this last one. I mean, see if you're good in this, because this is what we'll be kind of working on tomorrow. We'll be kind of working more with these. Double check attendance. All right, see someone answered. And while you guys are doing this, I'm gonna double check if I missed something. Tabby, I think you might have turned in something that I didn't put in the grade book, maybe. Can't remember. Let's see. Oh, I think I already put that in for you. Let me just double check. Oh, that's something you turned in. But do let me know if you see something like in progress book too, if something's missing, if you get a chance to check today or tomorrow. I put in one thing right now I saw in this. All right. Only one person answered the poll, but you are correct, whoever did. But maybe I'm guessing that means maybe we're struggling, or I don't know, maybe some of you guys are just distracted. But let's go over this. Do let me know if you are have any questions so far. Let me look at. Or I know sometimes the poll too, it gets like stuck behind the box and stuff. So that could have been the case. But so the first thing you want to do, like I said, step 1 is you basically just rewrite it as y equals like the equation. Step 2, you're going to swap your x and y. And crap, I forgot to pause the recording while I was having you guys work. So sorry for anyone watching this video. So you swap your x and y. Step 3, you want to get the y by itself. So you're going to add the 11 over. Can't combine it. So that would just be x plus 11 equals negative 5y, because that would cancel out there. So then you got to divide the negative 5 over. I usually just leave my answer like this. So like my answer, I would just write as the inverse is x plus 11 over negative 5. So that was actually like the first choice. Sorry, it's kind of maybe how I have the answers even written in the poll. Like obviously I don't have math type, so it looks a little weird. But you could also, like, one thing is you like when you have a fraction like that, you can also divide each part by it. So you could have also written your answer like this. So on that poll, actually answers A and B were correct. But so I just wanted, I think that's a good point to make, though, is sometimes when you're finding these inverse functions, sometimes how you write your final answer can look a little bit different depending on how you simplify or how you express like your fractions and stuff. So keep that in mind. Like for example, if I'm working on a problem and you're working on a problem, we both could be correct. It might just be that our answers look slightly different. So that's one thing with these we got to be careful about. Don't just assume you're wrong necessarily. I mean, if it doesn't look anything close, like, or you can't see a way like how to change your answer in the mind, you're probably wrong. But like I said, I want you to see, like, especially with these fraction ones, there's different ways to express in. Some people might have different preferences with how you leave your answers. Like different teachers might have different things they tell you. But this is kind of like the big concept. Usually this is like when you're talking about inverse functions, it's usually doing things like this, because that's usually where most of your actual applications are going to come from. Like I said, if you're ever in a science class and you have a formula, if you need to figure out how to work backwards, like a quick formula to like basically reverse your results, like an inverse, you're going to want to find an inverse function. Like if you have a conversion formula that goes from Celsius to Fahrenheit, if you solve for the inverse, you'd have a formula to go from Fahrenheit back to Celsius. So like I said, in science class, like a lot of times they probably just give you both formulas, but like if you needed to make one on your own or figure one out, like you'd want to kind of go through this process of finding an inverse function. But our last concept I just wanted you to kind of see is if you're graphing an inverse, basically you're going to see that it reflects, or basically your x and y values switch places. So I know this is kind of hard, especially since you don't have these notes in front of you. Kind of suck. The one thing that sucks about being online. But I'm going to plot these original points in red. So -2, -4 would be down here. 0, 1 would be here. 2, 6 would be here. Okay, so then we're going to find our inverse points. I'm going to put these in blue. So remember, to find the inverse of points, you just swap them around, like the x and y's trade places. So this is like what we saw in concept 1. So I'm going to plot these points that we just got, like our inverse points in blue, just so we can tell them apart. 1, 0 would be here, and 6, 2 would be up here. So one thing you're going to notice when you graph inverse points, it reflects over the line y equals x. I don't know if you remember back in geometry, probably not. But if you remember if you reflect over the line y equals x, basically your x and y values just swap. But the big idea, and you don't have to have points. Like if you had like a line or something, you would see it basically reflects over that line. But inverse points reflect over the line y equals x. So that's like what happens graphically when you're doing this. Let me check the chat. No worries. So